So our first example, how much heat will be released when 2.2 grams of propane combusts completely in oxygen. So here is the equation for propane, C3H8, combusting in oxygen. Combustion reaction, as we mentioned in the empirical formula videos, gives you the oxides, all the carbons turn to carbon dioxide, all the hydrogens turn to water. And I'm going to tell you that delta H for this is minus 2,200 kilojoules. So what's that telling you? Is that when 1 mole of C3H8 combusts, the heat change is minus 2,200 kilojoules. Should I react 5 moles of oxygen, the heat change would be minus 2,200 kilojoules. Every time 3 moles of CO2 are made, the heat change is minus 220 kilojoules. And considering separately, if 4 moles of H2O are made, then the heat change minus 2,200 kilojoules. Okay, so that is what this equation is telling us. It's telling us about the heat change for 1 mole of propane. Now, of course, I only want 2.2 grams of propane. How can I relate a mole to grams? Well, of course, I know that 1 mole of propane is equal to 44 grams. So when 1 mole of propane reacts, heat change of minus 2,200 kilojoules or 2,200 kilojoules of heat released, and that's the same as when 44 grams of propane react, because 44 grams of propane is 1 mole. So 44 grams of propane, 2,200 kilojoules heat released. 2.2 grams propane, how much heat is released? And the way we set that up is a little ratio. I like putting the masses on the one side, so 2.2 grams on top, 44 grams on the bottom. I don't know what the heat released for 2.2 grams is. I do know that the heat released for 44 grams is 2,200 kilojoules of heat. Now it's just a question of maths. Heat released, 2.2 times 2,200 divided by 44 equals 110 kilojoules of heat released. 1 mole of propane, minus 2,200 heat change, 2,200 kilojoules of heat released. That means 44 grams of propane, 2,200 kilojoules of heat released. 2.2 grams of propane, calculate it using a ratio, 110 kilojoules released. Do another one with just an extra little twist thrown in, and of course we will do examples of this in class. So how much heat will be released when 2.9 grams of butane completely combusts in oxygen according to, well, you might like, well, come on, this is just like the last one, except here's the equation for that. 2 butane plus 13O2 goes to 8 CO2 plus 10 H2O, delta H minus 5,600 kilojoules, because of course typically when we balance chemical equations we want to use the lowest whole numbers. In this particular case, if you think about balancing it, it would have been 13/2 O2. We don't like halves, so we have to take it to 2 butanes. Now what this tells us is that when 2 moles of butane combust, the heat change is minus 5,600 kilojoules or 5,600 kilojoules of heat released. Okay, 2 moles, 5,600 kilojoules of heat released. Now 2 moles is 2 times the molar mass of butane. 48 plus 10 is 58, so 2 times 58 is 116 grams of butane. So 116 grams of butane, 5,600 kilojoules. Now let's set up a little ratio in the same way. 116 is 5,600, 2.9, what we're asked is for the heat released. Rearranging that, heat released, 2.9 times 5,600 over 116 equals 140 kilojoules of heat released. So again, the 2 moles of butane is what relates to this heat change. So 2 moles of butane, 2 times the molar mass, 116 grams. 116 grams of butane is this amount of heat released. Pop that into the equation to figure out the amount of heat released for our particular mass.